as promised, well, as I promised myself years ago, probably decades ago, I've built a capacitor reforming unit. That sounds good, doesn't it? A CRU, a capacitor reforming. Basically, it's a power supply with a valve, pot on the front, variable voltage out here. I'm going to show you a series of photographs in a minute. I'm not going to wobble the camera all around this. I would have liked, well, eventually I will put a voltmeter on the front, which will give you a reading of the output, so when you turn the control, you know, you can set it to what you want. The maximum output from this is, I forget what it is now, 460 volts. The transformer I found is 230/0230. So that's centre tapped. Across the outside too, then obviously it's 460. That's what I've used. Full wave rectifier. I haven't drawn the circuit yet. I'll be doing that soon, so you'll see that later in the video. Right, and this is ideal for reforming capacitors, electrolytic capacitors, up to 450 volts DC working. So the one I've got on at the moment is a 275 volts DC working. So set the control for 275 output, series resistor. Good idea if you watch the capacitor reforming video that I made. Watch that in conjunction with this. What I might do at some stage is put the two videos together. Be about an hour long, but perhaps not that long. Okay, so let me show you these photographs. And I'll take you through how I built this. It's taken me 2 hours. Admittedly, I had all the bits and pieces to hand, but it's taken me a couple of hours, I think. Yeah, where are we? 9. Yeah, getting on for 2.5 hours. Right, let's have a look at the photos. I'm not going to spend too much time. Basically, I found a box. That was a brand new mains transformer I found, all packed up, new and boxed, from the 1960s, I think. There's a plastic box I found. Metal would have been better, but really doesn't matter. So there is the box with the mains transformer mounted. The next thing to do is mount the octal valve base for the valve. I'm using an octal valve in this case. I'll talk more about that a bit later. There's the 10k, the 500k pot mounted, on-off switch, indicator lamp. Just whipping through these photos fairly quickly because there's nothing special about them to show you. Underneath the box there's a little tag strip I put in. There are 4 diodes there. I'll explain that on the circuit. That's the full wave rectifier, 4 little diodes making a bridge rectifier from the 2 outer connections of the transformer. Okay, that's underneath, all wired up. You'll see I put a fuse in there. It's a 100 milliamp fuse. That's a bit high. I want something, I don't know, 40 milliamps will do, or even less. That's there purely to save the valve and the rest of it, just in case I accidentally short out the output. Yeah, there's the resistors. There's the 2 output terminals, which I found in my junk box. On-off switch. There's the pot, couple of resistors, all wired up, mains lead. Yeah, that's it. There's the unit connected up to a capacitor with the series resistor, 470k, and it's working. It's reforming the capacitor. I've got no metering on the unit. I'm going to put a voltmeter on the front, so I have to use my test meters to set it up. But basically that is the little unit, and as I say, that will reform capacitors up to 450 volts DC working. The lowest, I must double check this, the lowest voltage it'll give, I think, is about 60 volts. So you can't use this to charge, to reform, sort of 10 microfarad, sorry, not 10 microfarad, capacitors that are of a lower voltage. You can't use this to reform capacitors that may be 40 volts working or lower, like 25 volts, something like that. So there we are. I mean, I suppose you could reduce the voltage further with another sort of a rheostat or something, like I mentioned in the video about reforming the capacitors. But this was purely for my use. It's purely for HT smoothing capacitors, and it'll reform all of them up to, as I say, 450 volts DC working. Right, let's have a little chat about it. I've used an EL34 valve only because I have one knocking around. Right, what sort of current does... If you're going to use this as a workshop kind of bench power supply as well as reforming capacitors, you've got to work out what sort of current you need. This valve will pass, I think, at 90 milliamps, I think. My transformer is only, the HT of the transformer is only 60 milliamps. Okay, I haven't designed this to run radios or use it as a bench power supply at all. There's no smoothing in this at all. It's purely the bridge rectifier. I've got no smoothing capacitors, no smoothing resistor or choke or anything. It's purely just a rough DC out. If you're going to use it as a power supply to run radios or whatever, as a test power supply, you will need smoothing. We'll talk more about that later. Right, you've got to work out what maximum current it's going to draw. This is now purely for reforming capacitors. With a 470k resistor, that's 470,000 ohms, all right? Put that straight across the output and work out Ohm's law. Let's say this is, what did I say, it was 460 volts, 470,000 ohms. It's less than a milliamp. So even if your capacitor, say it happens to go short circuit or is short circuit when you first connect it up, don't worry, it's not going to do anything. It's not going to blow the fuse or wreck the valve, because you've got the series resistor, the 470k. So the most that you're going to draw from this power supply, well, it's less than a milliamp. You can work that out. 470k and whatever I said it was, 460 volts is the maximum. It'll be a little bit more if you use a 47k. You might remember in the other video about reforming capacitors, I had a whole bank of capacitors in parallel, and it total, I think it was 240 microfarad. So they will want more current, and the 470k resistor was too much, so I put a 47k in. So what I might do actually on the front here is put another switch where it perhaps chooses 2 or maybe 3 resistors, clonk clonk clonk, to choose, I don't know, 47k, a couple of 100k, then 470k. That's something I might do later. So yes, you only need a very small mains transformer. You don't need an EL34. Something small will do. Whatever you've got kicking around. An EL84 is good. You know, the B9A EL84, second-hand one of those. Any little audio output valve, any sort of pentode will do. I'll show you on the circuit a bit later on. So that's that. Yes, as I say, it doesn't go right down to 0. Because of the way the circuit's designed. I'll show you that in a little while as well. I'm going to put a panel on the front here so I can put a voltmeter there. What would be nice, if you're thinking of building one of these and you've got the meters and the box, to have 4 meters on the front. One reading the power supply volts, the output, the variable output, another meter reading the voltage across the capacitor, and another one reading the voltage across the resistor, the series resistor, and then a milliammeter reading the current. That would be great, but I haven't got meters. And unlike the old days, you could pick up a meter for 10 bob, 30 bob. I look on eBay now, and some of these meters are like £50 for a nice panel mount voltmeter. It's ridiculous. I'm not paying that for it. So I do actually have a meter here. That's 0 to 600 volts. What I might do is put a panel on the front and mount that there. That's just so I can set the output voltage on there. Possibly do that at some stage. Okay, I keep saying we'll get to the circuit in a minute, which we will. I'm just going through a few bits and pieces with you first. Right, coffee break. The choice of transformer. Let's say you're going to build this. Hopefully you are. If you're not, you're probably not watching. You're not watching this anymore, because there'd be no point. Right, choice of transformer. You need a mains transformer, obviously. You need 6.3 volt heater winding for your valve. do use a valve with 6.3 volt heaters. Don't use some obscure thing, because you won't be able to find a transformer for it. So your transformer requirements are your mains in, if you live in America, obviously 110, 115, whatever. In the UK, 230. Then you want 6.3 for your heaters. The HT, you want 400 and, well, at least 450 volts. The capacitors we are dealing with in these vintage radios, they're what, 370 volts, 375 volts, 300 volts, 250 volts. There are, I think that's probably about the lowest you want to go, 200 volts, up to 450 volts. So you want your transformer to be at least 450 volts. In this case, mine's 460. Now you can get that if there's a center tap winding, as I say on this one there is. It's 230, 0, 230. So the outside two are 460. So don't worry about the current. All right, this arrangement for capacitors is going to draw next to no current at all. If you're going to use it to run radios as a bench power supply, which I might do with this one at one stage, some stage, I don't know, then use a valve that will at least pass, I don't know, at least sort of 50 or 60 milliamps. Right, so that's your transformer. As I said, the valve, EL84, any sort of half decent audio output valve will do. Then what are our other components? A couple of terminals, a box to build it on, an on-off switch. Don't have to have an indicator light. I do like indicator lamps on things. I'm old-fashioned. There's a 6.3 volt bulb in there. I don't like LEDs. I don't like these modern little neons. I like a thing that I can see, so I know that is on. Unfortunately, the windings on this transformer here are exposed. I might make a plastic cover and sort of glue it over there. You don't really want to get any electric shocks, if I happen to go move it like that. So that's that. A bit of mains lead, of course. Bits and pieces, tag strip. Diodes, I use, what did I use? 1N4006. 1N4006. 4 of those to make a bridge rectifier. You can use a valve rectifier if you want to. That's up to you. That way you'll have 2 valves. I mean, there's nothing wrong with sticking another valve on top there. That way the HT will come up slowly. Seagulls are loud today. Must be a storm brewing. So, what else? Yeah, a fuse, as I said. I've put the fuse in the output. That's purely, if I happen to go and move something and short this out, then rather than spoil the valve or whatever, the fuse will just pop. Yeah, I've got 100 milliamp in there. Anything will do, anything low as you can find, 20 milliamps, something like that. Okay, I think that's covered all that. Put it all together, and then we better have a look at the circuit. At last, here's the circuit diagram. I used to have a computer program for drawing circuit diagrams, electronic ones. Had all the symbols, valves, diodes, resistors, pots. I don't know where it went, it disappeared. Okay, on the left is the mains transformer. Alright, suitable to the mains in your country. USA, 110, whatever. Europe, I think 230, wherever. That's obvious. I haven't drawn in the on-off switch, because that's pretty obvious. I haven't drawn in the indicator lamp. You might not even want one. That's obvious. Mine's a 6.3 volt bulb. So that goes onto the 6.3 volt tap on the transformer. Right, HT side. This is the important bit. HT, I've used 4 rectifiers there, as you can see. 1N4006. 4 of those wired as a bridge rectifier, it's called, like that. So you've got AC from the transformer going to the top of that diamond shape and to the bottom. Okay, then you've got the negative coming out on the left, positive on the right. Not going to say too much more about that. That's pretty self-explanatory, really. Just get the diodes around the right way when you connect them up. Otherwise they'll explode. The positive goes to the anode of the valve. Now you'll have to look up your valve connections, obviously, depending on which valve you're using. So, okay, positive out of the diodes goes to the anode. From grid 2 to the anode there's a 100 ohm resistor, so wire a 100 ohm resistor between grid 2, whichever pin that is, that's the screen grid, and the anode. Right, grid 3, as you can see at the top there, I've connected to the cathode. That's normally connected to the cathode internally on most valves. Just check on the valve that you're using that it is connected to the cathode. If not, then wire that grid 3 pin, the suppressor grid, to the cathode. Alright, it might be done internally, if not, do it externally. Now the control grid, grid 1, down the bottom there, 10k resistor, 1 watt will do, to the wiper of your 500k linear pot. You can see where that pot goes. The top goes to the anode, the bottom goes to negative. So this is pretty straightforward. You've got AC from the transformer, in my case 460 volts, to the bridge rectifier. Negative out of the rectifier there on the left, that just goes straight down and to the negative terminal on the right, the negative out. Positive to the anode of the valve, and positive, the variable voltage comes out of the cathode through the fuse to the positive out on the right there. Sorry, it's a bit of a naff circuit. I sort of scribbled it a bit. I was trying to find a decent felt tip and couldn't, so I had to use a ordinary biro. Doesn't matter, as long as you can see what's going on. What I might do, if I can, is get this computer program sorted out wherever it is, or get another copy of it and draw this out properly, put it on the website so you can see it. Okay, that's the circuit diagram. I said that the windings are exposed here. It's not the windings that are exposed on my transformer, it's the connections. All the connections are there exposed, so I'm going to have to put a cover over those. Keep an eye on the voltage. That's what I'm doing here. Keep an eye. Is that? Yes, it is running. 270. That's okay. The voltage will rise a little bit as the capacitor starts reforming and charging. The voltage will rise, so keep an eye on that. You might notice I've changed this pot. The shaft sticking out on this one. The original pot I put in there, I thought it was 500k. I can't see in my old age. It's not 500k, it's 250k, and it was getting warm. You don't want that. So I found, actually the one I put in there is 1 meg, linear, 1 meg, which works perfectly alright. I'll probably leave it at that. Should be 500k, that's about right. Linear anyway, 500k to 1 meg will do. What else have I written down here? Yeah, bear in mind that, as I say, you've got to adjust this. This isn't a stabilised power supply. If you're going to use this in the workshop, say to run a radio or whatever, you set your voltage to say 250 on your meter, set it to 250. As you run something from this, that voltage will drop, because you know, the drop through, as you start drawing current, the voltage will drop. It's not stabilised. It's a variable voltage power supply which isn't stabilised. You know, to be honest, you don't, to reform capacitors, we don't need a stabilised power supply. On the circuit, I didn't show the heater connections wired up. I just showed the heater taps on the transformer, the 2 connections. Obviously, they go to the heater pins on the valve. I'm saying all this because a lot of you will say, well, we know all this, but there are a lot of people that are learning, and you know, that's why I'm going through everything, although it might seem basic in some parts of the video. You know, you might say, well, obviously you connect the heater pins to the heater winding on the transformer. Yes, that is obvious, but if this is your first time ever building anything, then you know, you might forget that or not think about that because it's not drawn on the circuit. So bear with me. The capacitor's nice and cold. The valve pretty hot. These valves, the L34s, they get hot because it's a massive heater. I think it's nearly an amp. Is it? Or over an amp? I don't know. 900 milliamps the heater. I don't know. Whatever it is, doesn't matter. Okay, that's that. What else was I going to say? I can't remember now because I was waffling on. Yeah, there's the circuit. If, as I say, if you want to, what you can do, which I was going to do originally until I changed my mind, I found this transformer. What you can do is, if you've got a power supply, say you've got, I don't know, say you've got a DC power supply and it's 400 volts, 450 volts, whatever, then you can stick this on the end of it. Don't have the transformer, just on the circuit where the DC comes out of the rectifiers. Take the DC out of your power supply, put it straight in the anode of this valve. Alright, if you've already got a power supply. That's what I was going to do. There's the old wire wound rheostat from my old lab pack power supply up there. That's open circuit. I was going to take the voltage from that and then just put it through here to vary it. But the voltage there, the maximum is 300. I want 450 at least. I've got 460 now. So it's probably best, I mean, if you've got a power supply, as I say, stick a valve on the end of it. But it's probably best to build a sort of standalone unit like this. That way you can, let's just check this voltage. That way it's a sort of standalone capacitor reforming unit. What was it I said? CRU or something. I don't know. I do talk rubbish at times. Anyway, there it is. Is there anything else to say? I'm going to make a cup of tea. It's the afternoon now, so it's tea time, not coffee time. And I'll have a think, see if anything needs to be added to the video. Right, I've got my cup of tea. There were a couple of things. Smoothing. If you want to use this to run a radio or an amplifier, small amplifier, you've got your 6.3 volt heater connection, of course. Make sure there's enough current to run all the valves you're running. Make sure your transformer and the valve you use is capable of supplying the current your HT needs on your radio or your amp. And you will need to add smoothing. There's no smoothing on this, as I said earlier. So you will need to add, I don't know, a couple of sort of 47 microfarad electrolytics, you know, one either side of a resistor or a smoothing choke, as in a vintage valve radio. You'll need to add smoothing to it. That's that. The two resistors, the 10k and the 100 ohms. The other 100 ohms is wired between the screen grid of this and the anode. That's to give the screen grid volts. But the reason the resistor is there is to stop parasitic oscillations. And the 10k in the wiper or the slider of the control pot, there's a 10k resistor, if you remember, from the circuit. That's also there to stop parasitic oscillations. What they are, the valve can start to oscillate. It might take off, start to oscillate under certain conditions. So that's what they are there for. You don't want parasitic oscillations. Be careful. That's the other thing. You see me, I get overconfident. 271 volts. I get a little bit overconfident. I've been doing this for decades, and I'm saying, oh look, this is all exposed here. Look, that bit there. I ought to be careful myself, but this is the warning. I've got to say this. You're dealing with mains. You're dealing with, in my case, 460 volts. All right, the valve is red hot. You get burnt from that. Your capacitor there, I've got crocodile clips onto that. There's HT on there. It's one thing watching me wave my arms all around this stuff, and I haven't actually got electric shock as yet. I do get them. But be careful. Reforming capacitors is great. It's good fun. It's a useful thing to do. It saves old capacitors, but no capacitor is worth dying for. Just remember that. It's not worth killing yourself for it. So be careful. If you haven't built anything like this before, if you've never built anything, and you don't feel competent enough to do it, then don't. If you've got any questions, ask. Okay, ask me or someone else. Email me. Ask on the forum or the Radio Workshop Facebook page. Email me, whatever. Don't think, oh, I think that's right, that'll do, and carry on. Do find out first. And as I say, just be careful. Don't do this at home. I suppose I ought to say that. Don't do as I do, do as I say. Don't work on it when it's plugged in, when it's switched on. I do that sort of thing, but you mustn't. Okay, I think that's it. I think I've covered everything. If not, I'll be back in a minute, but I believe I have. So there is in fact more. I finished the video, I published it, I uploaded it to YouTube and everything. I went and had my dinner, and then I realised something. If you are going to add smoothing capacitors to this, you've got to be careful. Right, I've written this down because I'm dreadful at remembering things to tell you. Smoothing capacitors, right? This is a transformer that gives out 460 volts AC. Full wave rectifier, DC, will be 460 volts. Less a little bit, a volt or two drop in the actual diodes. Don't worry about that. If you add a smoothing capacitors to this and make a smoothing circuit, what happens is you have to multiply the AC output from this transformer, that's the AC coming out, our 460, multiply that by the RMS value, which is the 460, multiply, in other words, 460 by 1.4, and you've got 644 volts. Now, the way I just remembered this, I thought what I'll do, I'll put some smoothing capacitors in this before I put the bottom on. There's a bottom cover for this. I thought what I'll do is I'll chuck a couple of smoothing caps in there. Then if I want to, I can use it to power an amplifier or radio chassis or whatever. And I suddenly realised, I thought, hang on a minute, by doing that I'm going to up the voltage. Okay, let's just go through this again. The transformer is 460 volts AC output on the secondary, it's the HT. Rectify that, right, and you get 460 volts. Full wave rectifier, 460 volts. That's the RMS. What you have to do, if you add smoothing capacitors, it increases the average DC voltage. Adding smoothing capacitors increases the average DC voltage. All right. The way to work it out is 460 volts AC coming out of the transformer. Multiply that by 1.4 if you've added smoothing capacitors, and your DC will be 644 volts. Now, I just remembered that in time because I was going to add this. It's an 8 microfarad by 8 microfarad, two 8 microfarad caps in one can at 500 volts. I thought, well, that's fine, I'll use that, I'll stick that in there under the little box. That'll give me a couple of 8 microfarad smoothing capacitors, might even put a resistor between the two or whatever. And then I thought, hang on a minute, no, that's going to increase the voltage, which it did do, 644. So that 500 volt working would be no good, that would blow up. AC out of here, 460 volts. Rectify, a full wave rectifier, that is, you will have 460 volts. A little bit of loss in the rectifier, a volt or two, doesn't matter. Add smoothing, you have to multiply that by 1.4, takes it up to 644 volts. That's basically what I'm saying. I don't know what it is you're going to do. I don't know whether you're going to use your power supply for running amplifiers, radios or whatever, purely charging capacitors. If it's purely charging a capacitor, then don't put smoothing in it. If you want to run radios or whatever, amplifiers, make it into a bench power supply, then you're going to have to work this out. You're going to have to start off with a lower AC voltage out of your transformer. For example, work out that if you want 400 volts out of here, or say 460 to charge your capacitors, and you're going to smooth it, you've got to work out a lower voltage that when times by 1.4 gives you 460. I've just remembered when I was an apprentice in my sort of mid-teens, I built a transmitter. I was building a power supply for it, and I wanted sort of 350 volts. And I was looking for a transformer in the workshop. One of the older guys, he said, oh, you want a 250 volt transformer? And I said, no, I want like 300, 350. He said, no, you will want a 250 volt. He said, and he found one. He said, there you are, put that on your transmitter chassis, build your power supply with that. And I said, I'm only going to have 250 volts HT. Well, okay, you know best, So I built it. I had 350 volts HT. So, hope you've understood that, or have I totally confused the whole thing? If this is purely for reforming capacitors, then don't put smoothing in it. What you will find, as as I've said earlier, keep an eye on the voltage. Turn this down, you know, your pot. Turn your pot down as necessary, because this smoothing capacitor, the one you're reforming, will act as a smoothing capacitor, although it's got the resistor in series with it, for the power supply. So the power supply voltage, I've got 460 volts here. Okay, this actually will raise 460, 470, 480, 490. It will go up as the capacitor charges fully and reforms. So keep your eye on that. I think we're getting a little bit too technical. We're talking about reforming old capacitors from the 1940s. Let's not get bogged down with too much technical stuff. Okay, but I am glad I thought of that. I just wanted to, because you might think, oh, that's good. I've got, say, 400 volts, which is what I want. You slap some smoothing on there, you know, you've got some, whoa, voltage up here somewhere. Great stuff. This is all part of the fun of building your own kit. You know, you learn as you go along, and it's just good fun. So this time I have finished the video. I'm going. Bye bye. Thanks for watching. Bye bye.